Okay, thanks for joining me. We're going to go over the Trig Unit 8 Test Solutions, the problems that maybe you missed one or two of these and you just would like to see how they were done. So that's what I'm going to show you here. We'll start on the second section, starting with question number 7. We'll skip that first one. But I do have written down on my notes, a whole list of 32. I found 32 identities that I needed to have written down so that I could do this test. I didn't use them all, but I had 32 that we learned. Alright, so trig, let's see, question number 7, secant of theta over the tangent of theta. So I'm going to take a look at my notes here. I see that the secant is equal to the cosine, 1 over the cosine is the reciprocal, and the tangent is equal to sine over cosine. And so the strategy I'm going to use on this one, this is a pretty simple problem, is just to rewrite the whole thing in terms of sine and cosine. So secant equals 1 over cosine, and tangent equals sine over cosine. Now, just kind of thinking in basic arithmetic, this is a division problem. It's a fraction division problem. It's a fraction on top divided by the fraction on the bottom. So we can rewrite that as the first fraction, 1 over the cosine, times, so turn it into a multiplication problem. So the reciprocal, take that bottom fraction and flip it over. So cosine theta divided by the sine of theta. And now I can see that we have some common factors that can be crossed off in the numerator and denominator, and we're left with 1 on top and the sine of theta on the bottom. And then when I look at my notes, I see, 1 over the sine is equal to cosecant. So this is equal to the cosecant of theta. And that's as simple as we can make it. Can't do it any more simple than that. Alright, let's go to question number 8. Sine theta, sine squared of theta plus the secant squared theta plus the cosine squared theta minus the tangent squared theta. Okay, so in this one, as we're looking at this, number 8, I notice I've got a bunch of squares, right? Sine squared, secant squared, cosine squared, tangent squared. And that makes me think of those Pythagorean ratios, or the Pythagorean identities. So we're going to take a look at that, and we notice that we have several things that we see in our problem. We have a sine squared, we've got a cosine squared, we add those together, you get 1. We have a tangent squared, and we have a secant squared. The relationship there is that if you took the tangent and then added 1, you would get tangent squared. You get the secant squared. Now, I don't have a 1 that I'm adding to the tangent. In fact, what I have instead is I'm subtracting in the tangent, and I have a secant squared. So we should be able to recognize that this one can be transformed as that secant squared, and if you subtract the tangent squared from both sides, then that would leave the 1 all by itself on one side. So secant squared minus tangent squared equals 1. Okay, so that's what we're thinking about. And when we look here, we see, oh look, there's sine squared plus cosine squared. If we were to put those together, that would just be 1. And then we have secant squared minus the tangent squared. Oh yeah, we just saw that that is also equal to 1. And when we add them together, it equals 2. So this one comes out to be really, really simple, but we have to identify that these both are pieces of our Pythagorean identities. Okay, so looking at question number 9 here, sine x plus sine x times cotangent squared of x. So a couple of things I think about when I look at this mathematically. The first thing I think about is, well, I've got two things being added, right? Sine x and sine x cotangent squared x. And so it's a polynomial if you think about that. It's like, two terms being added. And they both have something in common, the sine x. So I think to myself, well, I could definitely factor that. So that's what I'm going to do here. Let's say, well, I'll take out that sine x. It's factoring is one way to take multiples of the same thing that occur in each different piece of the addition or subtraction, and just combine them into one thing. So it's just 1 sine x being multiplied by, if I take sine x divided by sine x, I get 1 plus sine x times cotangent squared of x. I just get the cotangent squared of x. Okay, so that kind of simplifies a little bit, but then when I see that cotangent squared, I think, of course, of my Pythagorean identities, and the one that has a cotangent squared in it actually says cotangent squared plus 1 equals cosecant squared, and we just got that, 1 plus cotangent squared. So by factoring out the sine x, I've got my cosecant squared now, and so I can write that's cosecant squared x times the sine of x. And then thinking about, well, what is cosecant? I've got cosecant squared, but cosecant is really 1 over sine, so cosecant squared would be 1 over sine squared. So that would be sine x. We'll write it as a fraction, because we're going to end up with a fraction here, 1 over sine. Now cosecant is equal to 1 over sine. Cosecant squared is 1 over sine squared. Alright, now when we put it that way, we can see clearly, oh look, there's a sine x on top, and then there's a sine squared x on the bottom. That just means there's two of them, sine squared, sine x times sine x. So we'll take one of them off, we'll cancel one of them out, and that gives me 1 on top, and the sine x on the bottom. Of course, sine 1 over sine is just cosecant, so there's a single cosecant x remaining. Alright, there's that the first three problems. Let's move on to number 10. Okay, so for number 10, cosine x over 1 minus sine x over cosine x. So we've got two fractions we're subtracting, and here we have to remember that in order to add or subtract fractions, we have to get the denominators the same, and the way that we're going to do that is by multiplying them by the opposite denominator. So I'm just going to take this first one, multiply by cosine x, top and bottom, and then the second one I'll multiply by the little bit more complicated thing, 1 minus sine of x, top and bottom. Okay, now, on the bottom, I'm going to have the same denominators. So I can kind of ignore that. I kind of just acknowledge that fact. Okay, the bottom is going to be cosine of x times 1 minus sine of x. But when you're adding fractions, once the denominator is the same, you kind of ignore the denominators, just have your answer has that denominator, and the numerators are what's important. So I'm going to take some time kind of fleshing out that numerator, and I'm going to kind of ignore the denominators. I'll recognize that the denominator is cosine x times 1 minus sine x, but I'm not actually going to do that. Okay, so the left-hand fraction, the numerator has become cosine x times cosine x, which is cosine squared x. And then I'm going to put the minus sign there in red, just kind of help me to remember that I'm really subtracting whatever the entire denominator, numerator on the left minus the entire numerator on the right. So I'll put a parenthesis there. So on the right, we have sine x times 1 minus sine x, so that's sine x times 1 is sine x, minus sine x times sine x is sine squared of x. Okay, so I put that kind of in red in the parentheses there just to remind me that that minus sign is going to get distributed across. So that's going to be kind of important. That's going to give me minus a sine x and then plus a sine squared of x. So if I wanted to, I could rewrite this as cosine squared x plus sine squared of x minus sine of x. And then remembering my Pythagorean identity, cosine squared plus sine squared equals 1, I can rewrite that again and just say, okay, so this part right here, that's just 1. So 1 minus sine of x. And that's the numerator, and I'm kind of taking my time simplifying that numerator. The denominator is still cosine of x times 1 minus the sine of x. And now I can see that we have the same thing. Factors, numerator and denominator, both have a 1 minus sine of x. So we can cross those off. And we're left with 1 over the cosine of x, which is the same as the secant of x. And that's as simple as we can make it. Okay, that was the first page, question number 10 there. And let's go to question number 11. So we have 1 over 1 minus sine x plus 1 over 1 plus sine x. Now here, when I see this, it makes me think of 1 minus sine x, 1 plus sine x. That should kind of call to mind this whole idea of if I had a minus b times a plus b, that would just equal a squared minus b squared. Okay, so that's kind of a polynomial factoring, polynomial multiplication, FOILing kind of thing. And the reason that's going to come up here is because we have this denominators that are kind of almost exactly the same, but not quite. One's 1 minus, and one's 1 plus, the same thing. And so, since they're not exactly the same, we can't treat them as being the same. We have to do what we did in the last problem, that is come in and multiply